Hello students, this lesson is on application of one-way ANOVA as a part of the course Statistical Methods for Psychological Research. After completing this module, the student will apply the one-way ANOVA concept to real-life scenario. They will be able to understand the computational background of the one-way ANOVA procedure. They will be able to interpret the findings from the analysis. In this particular part, we will discuss about the problem statement, framing hypothesis for one-way ANOVA. Now, we will discuss framing a suitable research question from the problem, framing a reasonable hypothesis, understanding the relevant steps to the chosen case scenario. In the previous video, we have learned what are the steps for performing the one-way ANOVA, starting from description of data, validate the assumption, level of significance, state the hypothesis, test statistic computation, critical value, statistical decision, and then finally writing conclusions. Now we shall state the current research problem. Distraction is a technique of diverting the patient's attention from unpleasant and painful dental procedures. A dentist wishes to compare the child's dental anxiety score using the Child Fear Survey Schedule dental subscale, abbreviated as CFSS-DS, during the procedure between three different pain management techniques. The pain management techniques are storytelling audio, musical audio, and audio visual distraction. Basically, the researcher wishes to compare between the anxiety scores obtained from these three different distracting techniques. As we discussed, we will start with the description of the data. The problem statement, the outcome variable is anxiety score that is obtained from CFSS-DS scale. The number of levels in that intervention is 3 levels. The number of children involved in each group is storytelling audio 5, musical audio 5, audio visual 5. Now we shall look at the sample values coming from these three groups. So we have 5 in each group. So in the first observation 22, it is representing the first group, first subject, and the last observation 42 is representing the anxiety score obtained from 5th child in the SA group. Similarly, we have obtained Y21, Y22, so on up to Y25. Similarly, we have Y31, Y32 up to Y35. Now we will look at the basic data layout for analysis using statistical packages. So we have two variables. First variable is anxiety score, which is the continuous variable. We call it as a dependent variable, and there is a second variable called group, that is called our independent variable, which is having 3 levels, SA, MA and AV. So with this we are ready for performing the analysis in packages. Now, assuming that for the explanation purpose, we assume that all the assumptions of one-way ANOVA are satisfied, and we are moving on to the further calculations. Now we go to step 3, fixing the level of significance at 5%. Next we frame our hypothesis. The null hypothesis is the mean anxiety scores are equal for all pain management techniques. Notationally, we will write mu1 is equal to mu2 is equal to mu3. Otherwise, we can state this null hypothesis as 3 pain management techniques are equally effective. Our alternative hypothesis is framed like this: the mean anxiety scores are not equal for all pain management techniques, or the three pain management techniques are not equally effective. In other words, we can say there is a difference in the mean anxiety scores between these three pain management techniques. So most people will prefer this style, there is a difference. Next, notationally we can also write mu y not equal to mu j for I not equal to j. So we are actually saying at least a pair of anxiety scores are different, then we are rejecting the null hypothesis. The next step is calculating the summary statistics. So, the summary statistics for one-way ANOVA are the mean and standard deviation. So, we are finding the three means. Y1 bar is the mean of the first group. How did you find that? We are going to add all the observation and divide it by the total number of observation in the group, that is 5. So, we are having 22 plus 23 so on up to 42 divided by 5, which is equal to 25.6. This is the first group mean, so that is Y1 bar. Similarly, we will calculate the Y2 bar, that is the number of, that is the scores added in the second group divided by the total number of observation 5. So, this mean is 44.4. Similarly, we will calculate the sample mean for the third group, which is 6 plus 10 plus 14 so on up to 13 divided by 5, which is equal to 25.6. Till now, we have discussed the description of the problem statement, the data layout for basic statistical analysis. We have fixed our level of significance. We have stated the null hypothesis and alternative hypothesis, and we have also discussed how to summarize the data in terms of mean. We will continue in the next video. Thank you.